welcome to Math is Fun with Amajoy. Hello and welcome to today's lesson. I hope you're all doing well. In our previous lesson, we learned numbers and we counted up to millions. We found place values of numbers and then we went further to solve some exercises of which I gave you assignments from. And then we went to integers. We saw integers on the number line, how integers can be subtracted on a number line. And we also learned that 0 is greater than -1, -2, greater than any negative number. I also gave you assignments from them. Okay, so for today we'll be seeing word problems and then we'll be seeing patterns and also fractions. So I hope you have your pen and your book ready. Let's get started. Okay, so word problems. When deciding how to solve word problems, look for keywords. More than, together, it means addition. Less than or different, it means subtraction. Times means multiplication. Share means division. So if you need to share something among yourselves, you are dividing. Okay, so share means division. Okay. So I have a few exercises here we could solve. I know this is just revision. I know you think you're far above this, but yeah, sometimes you could forget simple subtraction. It happens all the time. So I have a simple addition here. So the arrangement is what matters. So 3 plus 4, 6, 3 plus 1, 4, 6 plus 1, 7. So 7, 4, 6. That is for this. So let's go to this subtraction. 9, 2, 9 minus 3, 5, 3. So 9 minus 3 is 6. 2 minus 5 can't be, so we subtract. 12 minus 5 gives us 7. We are left with 8 here. 8 minus 3 gives us 5. So 5, 7, 6. Okay. So I trust you do this. You will find it in your Google Classroom. You submit it and then send it to me. Then I have some exercises here involving word problems. Peter has 840 stamps. John has 275 stamps. How many stamps do they have between them? So this is a very confusing sentence. So between them has been added there just to confuse you, because when we have subtraction, we have something we call find the difference between them. But it's straightforward. How many do they have altogether? That is what it means in simple terms. So we just take John and Peter's stamp of 840 and take John's stamp of 275. Then we add. So this is addition. 0 plus 5 is 5. 4 plus 7 is 11. Carry 1. This is 11. So 1115. I hope I'm correct. So you solve it and then see if this answer is correct. So that's what you're going to do under word problems. So you solve this word problems. Just to revise, let's refresh our memories again on this word problems. Okay. So now let's see patterns. So when looking for number patterns, work out the difference between two numbers next to each other. Work out the difference between two numbers next to each other. Then see if that rule works for the next two numbers. So when you work out this difference, we get something we call a rule. we get a rule. So we should see if that rule works for the next two numbers. If it does, then we'll use our rule to complete the pattern. Okay, let's give it a try. Let's find the fifth term in the following sequence. So we have a sequence here. 25, 20, and 15, right? So let's see if we can get a rule from those two numbers because they are close to each other. So 25, 20. We can make an observation with our eyes. So this is higher than this. So definitely there was a subtraction somewhere. So let's see what we get. 5 minus 0 is 5. 2 minus 2 is 0. So they subtracted 5 here. So minus 5. Then next we have 25. We have 20 and 15. So let's see if we subtract. Let's see if we'll get the same thing. Minus 15. So 20 minus 15. So it will borrow 1. 10 minus 5 is 5. 2 minus 1. So we've subtracted 1 from those two already. So now we have 1 minus 1, which is 0. Yeah, so we got another minus 5. So from here to here is also minus 5. Good. So now we can use the rule to complete the fourth term and the fifth term. So we've been asked to find the fifth term. We can't get the fifth term without finding the fourth term. Okay, so since our rule is now -5, we can now find the fourth and the fifth term. So 15 minus 5 will give us the fourth term, which is 5 minus 5 is 0. Bring our 1 down, get 10. So that is the next number. So we do the same thing here. 10 minus 5 is 5. So this is our fifth term. Using rule -5, okay, so this means that at every point in time they deducted 5. So 25 minus 5 will give us 20. 20 minus 15 will give us 5. Sorry, 20 minus 5 will also give us 15. Yes. 15 minus 5 will give us 10. 10 minus 5 will give us 5. So that's it for A. Now let's go to B. Let me just wipe this off. Okay, this is not visible. Okay, so for B, let's see the difference we can spot. This is 40, this is 32. So what rule can we make out of this? We can see it's going in a descending manner. So anytime you see it's going in a descending manner, meaning there should be something that is being deducted from one of them. So we have 40 and 32. So we've agreed we should subtract. So we borrow 1 from this to give us 10. This will give us 8. Remember 3 here, so 3 minus 3 is 0. So could it be that they are subtracting 8? Well, let's see. Let's solve the next one. So 32 and 24 are together. and solving C. So this is 12 minus 4, 8. 2 minus 2 is 0. Well, yes. So we've gotten 8 twice. So meaning the rule here is minus 8. So at every point, oops, at every point, they deduct 8. At every point, 8 is being deducted. So then what would be the next one, which is the fourth term, and then we can find the fifth term. So that is 24 minus 8. So this is 14 minus 8. We borrow 1 from 4. So we get 6 here. Remainder 1 here. So we get 16. So from here to here, the rule was minus 8. Let's do same for the fifth term. That is 16 minus 8, which is 8. So the fifth term is 8. So 16 minus 8 is 8. So I want us to see something else. So mathematics, there are different ways to solving a particular question. So with the A and B, if we turn it around from the fifth term to the first term, what can we see there? We can see 5, 10, 15, 20, 25, and so on. So these are multiples of 5, right? From the other ones, we can see 8, 16, 24, 32, 40. These are multiples of 8. So it's multiples of 8, 10 in an inverse manner. So just in case you can spot that when you're about to solve, you can use that as your rule to complete the sequence. Okay. So that's it. I'll let you solve this. And this is just for you to fill in the missing numbers. So 11 times what to give us 44? Well, 7 plus what to give us 15? These are very, very simple questions. And these are the fraction form. These are the fraction form of it. Taking this 5 over 3, the next becomes 4 over 3. So why is this 1? Why is this 1 and not fraction? Why is this a whole number? So I want you to leave this answer in the comments. So send me a private comment on Google Classroom with your answer as the reason why this is 1 and not a fraction form. Okay, let me see how well you're thinking mathematics. Okay, so fractions. So fractions are in the form of some number over some number. The some number could be anything. This could be A over another number. This could be B, anything. I know A is not a number, but in mathematics we represent numbers with alphabet. So A could be a number. So the bottom number is called the denominator. Bottom number, denominator. And shows the total number of equal parts something is broken up into. Okay. Shows the total number of equal parts something is broken up to. So I have a chocolate bar, and this chocolate bar can be divided into 12. Let's see if I will get to 1, 2, 3, 4, 5. Can be broken up into 12. So let's say I have 12 chocolate pieces, and then I have 6 siblings. I have to share this chocolate bar among 6 siblings. So remember yesterday in our previous lesson we talked about division being sharing. So if you're sharing something, you are divided. So now you can see the relationship here in fraction. So I want to divide this 12 pieces of chocolate amongst my 6 siblings. So meaning I have to share this into this 6 equal parts. And that is why so I'll break this chocolate bar into 6 parts. So the 6 parts, my 6 siblings become my denominator. Then the bottom number, which is called the denominator, the top number is called the numerator. It's called the numerator. So the top number is called the numerator and shows how many parts we have. So how many chocolate parts do I have? 12 chocolate parts, correct. So 12 over 6. So this 12, I'm sharing this 12 chocolate pieces into 6 places because I have 6 siblings. This is the chocolate. So they said, for example, the fraction 3 over 4 shows that something is made up of 4 equal parts. And we have 3 of this part. So let's say a cake or a pizza. So pizza is mostly the best example I like to use. So I have a small pizza size with 6 slices. 1, 2, 3, 4, 5, 6 slices. So this is a whole pizza. And in my family we are 6. Okay, let's say we are 3 in a family. The 6 of us can share a small size of pizza. Hypothetically. So I have 6 slices of pizza. 6 slices of pizza. And I want to share it among 3 of us. So this 6 slices is the whole pizza, the whole thing, which is the numerator, over how many people do I want to give it to? 3. So the 3 becomes the denominator. Yeah. So when I do my calculation, 3 goes here 1 and goes into 6 2. It means each person is going to get 2 slices. So that's why when you have a situation, so you've bought biscuits and then you meet your friend, so you meet 2 of your friends on the road. And okay, so then let me just say you meet one of your friend on your way back from buying the biscuits. And in the biscuits, probably we have only four biscuits in a pack. And then your friend comes for you to give her some. There's only 4, so you have to stop for a while and do the calculation so that no one cheats the other. So okay, I have 4 biscuits and we are 2. So 4 over 2. Each person gets 2. The same thing, sometimes you can have biscuits which is 5 inside it, and then you're only 2. Then you would have to do the calculations. Okay, so I'll give you 2.5, I'll take 2.5. Yes, that is fraction coming into play there. So you have something and then you are dividing it into equal parts so that no one gets cheated. So the thing you have is the numerator, and how many of you want to share it? That's the denominator. Okay. So changing fraction to decimal. To change a fraction to decimal, divide the numerator by the denominator. To change percentage to decimal, remove the percentage sign and move the decimal point 2 places to the left. So it depends on what you are doing. So to change a percentage to decimal, so let's say I have 20% per cent. So I have 20% and I want to change it to decimal. So they said we should remove the percentage sign. This is the percentage sign. It has a stroke and then 2 zeros. This can be rewritten as 100 over 100. So they said we should replace this percentage sign with over 100. So because it is percent, by default, we'll move the decimal places twice because this 1 year signifies a point year that is always there hidden, and this 0 year means the number of times we'll move it. So 1, 2. So we've moved the point twice to the left. So this is 0.20. Mostly the zeros at the back here are insignificant, so we have 0.2. So all 0. Yeah. So that's changing percentages to decimal. It is one of the easiest conversion you can get in mathematics. Converting percentage to decimal. It is so straightforward because you have your denominator to be having 1 and 0, so you don't have to do too much working. So to change percentage to a fraction, remove the percentage sign, put the number as a fraction with 100 as a denominator, and simplify the fraction if necessary. So what we did previously here was changing the percentage to decimal, but here we are going to change percentage to fraction. So this is also very simple. So it's the same process. So the same 20%. So 20 over 100. So this is our denominator. So 20% is equal to 20 over 100. So this is 20. So over 100. They said we should simplify the fraction if necessary. So it is necessary here because this 0 can cancel this 0. So we are left with 2 out of 10. 2 out of 10, they are even numbers. 2 can go into this and 2 can go into this 5. So my answer is 1 out of 5. So 20% is equal to 1 out of 5. As simple as that. Let's take 25%. So 25%, we have 25 over 100. So this implies we do a simplification here. So 25 goes, so what can go into 20? 25 can actually go into 100, but I want to do it step by step. So 5 can go into 25 5 times, and 5 can go into 100 20 times. Yeah, 5 over 20. 5 can go into itself 1 and go into 24 times. So therefore, 25% is equal to 1 over 4. As simple as A, B, C. Okay. So here is an exercise for you. We would need to write the following as fractions. So 1/5 just means 1 over 5. Yeah. So you do the rest. Then what fraction is shaded in the following diagrams? So this is A, this is our B, and this is our C. So I'll do the first one. So take this as a medium-sized pizza. I have 1 slice, 2 slices, 3 slices, 4 slices, 5 slices. So let's say it's a small size pizza. And then my little sister eats one of the pizza. So we've shaded it as green. How many do I have left? That's one, two, three. How am I doing that? One, two, three, four. So now I have. So she has eaten one pizza out of one, two, three, four, five pizzas. So sometimes you'll be asked, what do we have left? So what we have left is just four out of five. So this is the pizza that she has eaten. So the question is asking us to find the fraction of the shaded pizza slice. So in this case, we'll take the shaded pizza slice as a pizza that has been eaten. So sometimes the question can ask you what portion is remaining. So that is when we'll count this, that. And we get 4 over 5. So this is what is remaining. But this question requires us to find the one that has been shaded. So the one that has been eaten. So I expect you to do the rest and send it to me in Google Classroom. Okay, so yeah, we need to place the following decimals on a number line. Yeah, on a number line. So from here, you can just start counting from 0. Between 0 and 1, there are several decimals, millions of decimals you would have to face in reality before you get to 1. So these are the several decimal parts we would have to meet. So from here we have 0. The next one should be, it depends on the on the on the on the intervals. So from 0 I have 0.1. So 0.1. Yeah, I have 0. The next one is 0.25. So from here I can have 0.15 if it requires. Then I can now have my 0.2 here. And here asks for 0.25. So you can just, I've done this check. I've done this check. So what's next? So let's keep on going. So 0.3 here. Next one here is 0.35. Next is 0.4. So 0.4 is here. Check. 0.45. So check. Next is 0.5. Check. 0.6 is next. Next is 0.65. Check. 0.7 here. Check. 0.75 here. So and so on till you get to 1, or till you finish checking out everything on the list. Okay, so I would want you to do this and send it to me. Do it neatly, not as I've done it zigzag. So you just draw a number line. Everything should be on the same plane. So 0.1, 0.15. So in this form, 0.2, well arranged, 0.25, and so on. So this is how I would want you to do it, not like this, but like this. Okay. So yeah, we have to calculate the following. So this is addition of decimal fractions of decimals. So 1.2 plus 3.4. So this is 6 1 plus 3 is 4. So you can see my points are all on the same line. So here is one thing I like to do when I have a confusing format like this or like this. So what I like to do first is to put the points. So the points will help me arrange it. So if I'm solving, let's say C, and I've place the point, I know after the point I have 2. After this point I have 3. Before this point I had 0. So you see how I'm arranging it. I'm using the point as my guide. Before this point I had 5. So you do your addition. Then you put the points before you get your answer. So arrange it. The precision of your arrangement will give you the precision of your answer. If your arrangement is right, your answer will be right. If your arrangement is zigzag, your answer won't be correct. So let's solve E and C. So with the same guide, my decimal points first. So for 3 points, 4, 3. So I know after the point I have 4 and 3. After this point, I know I have 3. You see, it's after the point that I have the 3. So the 3 can't come here. Before this point, I have 3. Before this point, I have 2. So this is 3. So it's subtraction. So 4 minus 3 is 1. 3 minus 2 is 1.13. Okay. So you do the rest and send it to me in Google Classroom. So that's all for today's lesson. I hope you really enjoyed the class. If you have any questions, feel free to contact me. And don't forget to go to Google Classroom to get the assignment I have prepared for you. Till we meet again, keep practicing, practicing, and practicing. Bye bye.